Hello students, Jai Swaminarayan. I am Professor Urvish Mewada, HOD Electrical Department, Sri Swaminarayan Institute of Technology, Gandhinagar. I am the subject matter of Interconnected Power System, which is in the 7th semester Electrical Engineering, and GTU subject code of this subject is 2170901. Students, we are discussing the chapter number 2, power system matrices, and this is our uh, in last lecture we have discussed the Zbus algorithm, and in this lecture of say lecture number 4, so this is the subtopic of lecture number 4, that is topic number 4.1. Let us discuss the examples based on Zbus formation. So for chapter number 2, uh, the power system matrices, and this is the topic number 4.1, that is uh, example based on the Zbus formation. So let's have consider one system having we are for that we are going to find the Zbus. So this is the bus bar. This red lines indicate this is the bus bar, or this whole system is called the interconnected power system. So in this we have four buses, means 1 2 3 and 4, and these are the lines which connects, interconnected line which connects the each and every bus bars. So there is a connection between 2 and 3, then 3 and 4, and 4 and 1, then 1 and 2, and between 4 and 2. So this is called the links. So this connects the each and every bus bars or generating stations with each other with the help of line, and this is the line reactances. So this J03, J015, J04, J025, J01, J02 and J01 0.1 is the line reactances. This yellow numbers indicate these are the lines, and here this generating station, this two bus bars are grounded over here. So the single line diagram of a power system is basically shown over here. So the line impedance in PU, generally it is per unit, because uh, um, it is it will be very easy to calculate the whole system. So that's why for each and every units of the power system, the data must be calculated in the PU. So the step-by-step procedure for Zbus matrix formation is basically explained over. Let us see. So this is the preliminary step. So first of all, we draw the graph of this the system. So in this we have the tree and co-tree. So this is the tree, this is indicates the tree of this. And what is tree? It includes all the nodes, but doesn't contain the closed path. So with the help of 5 4 2 and 1 we form the tree, and this is the co-tree. So 7 3 and 6 is the co-tree, or we can say 5 is the 5 4 2 and 1 indicates a branch, and 7 3 6 are the links. So the graph of the network and the tree is shown in the see elements 1 2 4 and 5, and there are the branches of 3 6 7 are the links. So this is the graph. First of all, we need to draw the graph of any network to solve the network. So this is the graph of the previous diagram. Now step 1, uh, the step-by-step Zbus matrix building algorithm starts with the element number 1. So in this diagram, see, this is the element number 1 for which we are start writing the Zbus. So see, this is the tree branch, so connected between nodes 1 and reference node. See, this is the node 1 and this is the reference node, and uh, uh, and sorry, node 1 and the reference node 0, and it has the impedance of, say, it is written over here j01, j0.1 pu. So this is shown in the accompanying figure. This figure shows that there is a this is the branch in which we are, for which we are finding the ZBus. So this branch is added, suppose. So this is the node added and this is the branch added. So this is the partial network of the step 1. So if we want to write the ZBus matrix for this, then Z120, this is number 1. So Z120 is J0.10. So this is the ZBus for this link only. Now let us consider step number 2. So we have added another branch. So node added number 2, the node which is added, it is number 2, and this is the branch which is added, having the reactance is 0.1 pu, j0.1 pu. So the element 2 connected between node 2, this is indicated as q is equal to 2. The reference node 0 is selected. The element has an impedance of, say, Z20, because we are finding from 2 to 0. So it is 0.10 pu. So as this is the addition of tree branch, it will be added a new node to the existing ZBus of the previous slide. So this addition is illustrated as below. So the ZBus will become J 0.10, and the impedance of this link is Z220. So this indicates that 1 to 1. So 1 is J0.10, and 1 to 2, there is no connection, so it is 0, and 1 to 2 again, so there is no connection, so it is 0, and 2 2, so the impedance of this, it is Z2.0. So sorry, Z20, so Z220 over here. Now this will become, this is the J0.10, that is Z11 over here. So it is we indicated in the previous case, and this is Z12, so it is 0, 1 to 2, there is no link, and Z21, it is again 0 because there is no link, and Z22, so 22 is 0.10. So this is how we can form the ZBus, because we added the link. Now step number 3, the element 3 connected over here, this is the link branch, and the impedance or the reactance of the line is J0.2. So node P is equal to 1, and node 1 is equal to P, and node 2 is equal to, means Q is equal to 2, having an impedance of Z12, that is J2.0 pu. So it is added to the partial network as shown in this figure diagram. Since this is an addition of a link, because this is the link in the our graph diagram that we drawn in the second slide of the main SLD. So since this is an addition of the of a link to the network, a two-step procedure is to be followed in the in the first step, a new row and a column is added, and matrix is given as, for this particular network, means Z temporary bus, means we are writing this Z bus temporary. So Z11, so 1 to 1 it is 0.1, that we already discussed, means this is the first addition of the first link. Now Z1 to 2, Z1 to 2, so 1 to 2 it is 0, because we are considering Z1 2, so this is the link, so that it is 0, and Z L, the link which is added over here, for the red mark, so 1 to 2 minus 1 1, 1 to 2, Z1 to 2 link added, so Z1 2 minus Z11, so for this it is minus J 0.10 from this, so Z11 that is 0.10, and Z12 it is 0.2, so Z12 is 0.10 minus 0.2, so it is J 0.10 over here, and we means this is the Z21, so this is the link, that's why it is 0, then Z22 it is Z22 it is 0.10, that we already discussed in the previous slide. Now Z22 minus, this is the link which is added, Z22 minus Z, this is the Z22, means Z22 minus Z21, so 22 minus 21, so it is J 0.1. Now this is the column matrix, so this is the means this is the row matrix, so this is Z12 minus Z11, so it will become the reciprocal of this first term, so Z12 will become Z21, Z11 will remain the same, because if we interchange the link and means the row, so it will become as it is, so Z21 minus Z11 and Z22 minus Z12, so this will become minus, and this term we are following, we will put this term over here, so minus J.10, and this is this is minus this is J 0.10, so ZLL, so which is the link added at it is it is an addition of all this, so this will become 0.40, so this is how we can form the matrix for the all three branches, means one is link and two, the rest two are the branches. So let us see, where ZLL is the Z11 plus Z22 minus 2Z12 plus Z20, so this is the formula for the ZLL. So we have all the values of Z11, Z22 and Z12 and Z20, so by placing this value we will get the value of ZLL, so use this formula to find out ZLL. Now the next this new row and column is claimed to restore the size of Zbus matrix is basically given below. So this was the old matrix and this is the new one. So Zbus is equal to J 1.0 sorry J 0.10, and there is the link, there is no link between Z 1 2, so it was 0 and this is 0.0, because there is no link between 2 to 1, and this is the 2 2, so that is J 0.10. Now from this is the values that we use over here. So by putting this value over here, means new matrix value over here. So it the impedance matrix after the addition of the element 3 is found to be Z bus is equal to Z11 is this, Z12 is this that we solve from this, and Z21 is this, means 0.025, and Z22 will become this, means 0.075. So by solving this we will get this Z bus. Now step number 4, now we are putting the element number 4, which is added next in the which is connected between an existing node 2. So that's why P is equal to 2, and the new node means and a new node number 3, Q is equal to 3. The impedance of this element is Z23, because we have added the node number 3 and it is connected between 2 to 3, that's why it is 2 3, so 0.30 pu. And it is a tree branch, so a new node 3 is added to the partial network. So this addition shows the in the figure, means diagram. So thus the increases the size of ZBus, and that will become 3 by 3. So uh, for the third node, it is the reactance, or the line impedance is J 0.3. So we have the connection between 2 to 3, okay, but there is no connection between 3 and 1, okay. So uh, uh, the Z11 will have the value that this is our old matrix that we derived in the previous case, this one, okay. By placing this one, now this is the Z12 Z13. So Z13 is the impedance of the 1 to 2. So here we put the value of Z12, then here Z21, Z22, and this will be Z22, and this is the addition of this two, Z22 and Z23, means Z22 is uh, 0.0, this is the printing mistake, 0.075, and Z23 is 223 is Z22. So let's we put the values of all. So we have 223, means 23 is J 0.3. So by placing the value over here we will get J 0.375, and Z12. So Z12 is already we have this one, and Z22 sorry, Z12 is already we have 0.025, means this is the old matrix. Now Z13, so Z means this is the addition of, means we are putting the value of Z122. So this is 0.025, because this is the old, we are putting this because we are finding the value of Z13. So that's why it is 0.025, because this is the addition of the node 3, and this is the column matrix. So put this value 0.025 over here, so this will become the same, Z21, and Z22 will become 0.075, and this is the Z22 plus Z23. So here from this we can say that this is the new ZBus when the link is added to the reference bus. So this is the means reference bus. So we have only 3 nodes, 1 2 and 3, that's why this matrix is 3 by 3. Now step number 5, the element number 5 is added next to the existing partial network. So this is again a tree branch, so connected between an existing node 3. So that's why P is equal to 3, and the new node Q is equal to 4 is illustrated. So that's why the matrix will become 4 by 4. so 4 row and 4 column. So the impedance of new element is 3 to 4 is Z34 is 0.15 pu. So it is drawn in the this diagram. So let's have the Zbus formation for this. So for this one, for this fourth one, this will become Z31, because we have considered the 3 by 3 matrix in the previous case. That's why this will become 3 1, then this will become 3 2, and this will become 3 3. Similarly for Z33, Z23, Z13, the formula for this diagonal matrix is Z33 plus Z34, Z33 plus Z34 means 3 to 4. So it is already given Z34, it is 0.015. So by placing this 0.15, we will get 0.0525. So Z31, it is 0.025, and Z32, so it is 0.075, and Z13 will become the reciprocal of this one. So just place this value over here, and the second column vector, put the value over here, and third one is over here. But the diagonal matrix will become Z33 plus Z34. So just put the value of Z34 over here, so we'll get the value of diagonal matrix 0.0525. So this is the new row and column which is added by adding the element number 5 in this the graph of the SLD single line diagram, which is given in the data. Now step number 6. So the element number 6 is connected between two existing node. One means P is equal to 1 and node Q is equal to 4. So over here, so it is added to the network. So as shown in this figure B, so this is the partial network for the step number 6. This is the diagram for the step number 5. The impedance of the element is Z23, means 223 is 0.25 pu. So it is again we can say Z41. So this will become 0.25 pu. So as this link is the addition, so two-step procedure is used, and the bus impedance matrix is modified by adding new row and column. So let us consider this one the old means Zbus. So the new one is Z14 minus Z11. So this is the link. For this link, the equation is Z14 minus Z11. See, Z14 minus Z11, because we added this link, and this for this one is Z24, because we are considering for node number 2. So 24 minus 21, because 1 will become 2, 3 and n, and this this is the this is for the link number 1. So means node number 1. So 1 1 1, and this is 1 2 3 4 for the branches, and this is the link which is added for number 4. So for this is how we can write the equation for Zbus for the new link which is added in the matrix, sorry, in the circuit. So Z24 minus Z21. So Z Z24 224 is this one, minus Z 21. So Z21. Now for the third third column, third element of the column, which is z34 minus z31. So this is the reciprocal, this row is the reciprocal of the column. So 4114 will become 41 and z11 remains same, so z41 minus z11, and z24 will become 42 minus z12, and z34 minus 31 will become z43 minus z13, and z44 minus z41 will become z44 minus 14. So this is the zll, and zll is the means as we use in the previous case. So see in this, so zll is again z33 plus 34 for this one. Means 3 means we have connected this at the number 3, this link is connected at number 3, and means this is the relation between 3 4. So 3 plus 3 4 over here, so this will become z44 minus z41, so zll plus z44 minus z41. So this will become, we have the value of zll, in the z44 we have the value z44 is 0.075. This is the value which have z44, that is 0.075 from the old matrix, and then the z11. So z11 is again we have the sorry z this is the this value is interchanged. Z11 is 0.075, so this is 0.075, and z44 is 0.524 minus 2 into z14. 14 is 1 line 1 and 4, so it is 0.025 plus z14. So z14 it is given in this 124, it is given 0.25. This is the value. So by placing this value we will get this equation, means that get the value of zll. Say if the link is added, then this is called the means zbus for the fourth link which is added, sorry, for the sixth link which is added in this. So zll will become 0.80 pu. Now the additional the additional row and the column L are to be eliminated, means in the previous bus, this one. So for this we will use zbus old minus zbus new. So 0.05, see this is the row will become the column. 0.05, 0.50, 0.35 and 0.50 into the this is the column, sorry, this is the column will become the row. So 0.05, 0.05, 0.35 and 0.50. So this is the row which in the previous case, and this is the column divided by the value of zl, the zll which we calculated. So from this sorry, we move into the next slide. Okay, sorry. Now we need to eliminate this additional line. So by putting this formula zbus old minus zbus new, so if you solve this, you will get the link number 4 up to link number 4. Means this will become this is the old one matrix, and this is the means after solving this we will get this one. So number 4. So this is the after means putting the link number 6. This will be the ZBus for this particular network. After solving this means ZBus new, ZBus old minus ZBus new, so you will get this ZBus. Now for the step number 7, finally element number 7, so that we are adding connected between two existing node 2 means and node 4. So this is the link and which is added to the partial network of the step number 6. Now in step number 6, till that we have the this one, you can see this is the blue line. Now this red one is the addition in the step number 7. So the impedance of the element is Z23 is equal to J 0.40. So Z23 is J 0.40. Over here we are considering 23 because this is the addition, so we consider the previous case, so Z23. Now this is also a link addition, so as shown in figure means below, two-step procedure will be followed to obtain the ZBus matrix. So in the first step, means temporary bus is calculated after row and column are added to the existing ZBus. So we are adding the row and column in this existing bus. So this was the existing from the previous case. Now this one is the link added. So this will become Z14 minus Z12, Z14 minus Z12. Okay, so these are the formulas for to find out this new link. So Z24 minus Z22, then Z then so these are the formulas for the new link which is added. So follow this one. So by placing these values we will get the results for this particular link added. So for this row, the reciprocal of this layer, the column link formula. So see over here you can see that Z14 will become Z41. So from this we can have the, so after solving this we will get the ZBus means after the calculation. So substituting all the values, the element of the impedance matrix one get this values. So ZLL formula for this one is Z22 plus Z44 minus 2 into Z24 plus Z24. So by placing these values we will get the value of ZLL. So it is 0.5969. Now the additional row and the column are to be eliminated to restore the impedance matrix size m cross m. So and ZBus after the addition of the element number 7 is calculated as, so this one is the old minus new. So by solving this we will get this ZBus, and as can be can be seen that the final ZBus matrix is 4 by 4 because we have total 4 nodes in this. So as the network has 4 nodes, a reference node and the reference node, as there are 7 elements is in the network, 7 steps are required for the formation of the ZBus matrix, because we have the 7 elements and we have the 4 nodes. So the ZBus will become 4 by 4 matrix. So this is the final ZBus after after solving each and every by placing each and every elements in the means step by step. So this is the final ZBus after calculation. Now the modification in the existing ZBus can be done by, if an existing network for which the ZBus matrix is known, so some modifications such as line removal or line impedance, then the alteration is carried out, then the ZBus matrix can be easily modified. So over here 1 by Z24 result is equal to 1 upon Z, this org indicates original, and plus Z24 is the addition, so this will become 1 upon infinite. So that means it is 0. So here we have taken one like removal of the element number 7 is the equivalent to the say setting its impedance 24 to infinite. So this can be obtained by connecting the fictitious element 24 in parallel to the existing element. So let us see how it can be connected. So this is the parallel element, means which is the link which is added. So for this Z24 old sorry addition is equal to Z24 is equal to Z, just a minute. Now from this we can say, as an example, the Z matrix is to be the final bus impedance matrix given for the network of the single line diagram that we already derived in the previous slide. Next, let the element number 7 connecting node 2 and 4 be removed, means we are removing that link from the network, and it is required to find out the modified Z bus. So for the removal of the element number 7 is equivalent to the setting its impedance Z24 that we already know in the from the previous case to infinite. So this is the formula which indicates that the removal of the link will become the infinite impedance. So this can be obtained by connecting a fictitious element, so Z additional Z24 additional that we are connecting over here in parallel. So that's why the Z24 original plus 1 upon Z24 the additional. So the element Z24 original such that the resultant impedance Z24 the result is infinite. So let us see. In this we are adding this link, so this red line indicates the addition of the link, and having the impedance is Z 0.4 pu. So means Z24 additional is equal to minus Z24 original, so it is minus J4 0.40 pu. So hence by adding the element 24 is equal to Z 0.4 pu in parallel to Z24 original. So the removal of the line between nodes 2 and 4 can be simulated by this. So the new added fictitious element is a link. So this is the link which is added between two nodes 2 and 4. So and it is shown in this diagram. So hence this will require a two-step procedure. So the addition of the fictitious element 8, this till this diagram we have the 7 element, this one is the 8th element, so which is the link. So we'll introduce a temporary row and column. So this is the temporary row and column for the ZBus temporary. So this will become Z14 minus Z12, and the Z24 means 1 2 3 and 4. So Z1 2 3 4, and this is the node at which we are finding, that's why this is Z4. And again Z1 2 3 and 4, this is the relation between each and every nodes. So at the node we are finding this is the second point of the node, means link, so 4 and 2, so that's why it is 2 2 2 over here, and 1 2 3 4, this is the relation of the means rest of the nodes, sorry, links with the node number 2, and this is the link number, means node number 4. That's why it is 4 over here, and 1 2 3 4 are the relation of all the branches links with that node. So by putting this formula 1 4 minus 1 2, then 1 4 will become 2 4, minus 1 2 will become 2 2, then 2 after 2 that will become 3 2 and 4 2. So this is the column vector, this is the means row vector, means sorry, row impedance. So row impedance will become the reciprocal of this column matrix. So this is the 1 4 will become 4 1. So by placing the reciprocal of this, we can form the ZBus. So ZLL now formula for ZLL is Z22 plus 24. So Z22, here from here we can find Z22, then Z44 minus 2 into Z24 plus the addition of the link, so Z24 additional. So by placing all the values, we will get the value of ZL. So it is minus J 0.2681 pu. Sorry. So the additional row and column is eliminated by ZBus old minus ZBus new. So just place the values of all the rows and column over here new. So the final impedance matrix that after the removal of the element number 7 is this one. So we have the 4 nodes, that's why the matrix which is formed, that will be 4 by 4. So the obtained ZBus matrix is indicated, see it is identical to the ZBus matrix obtained in the step number 6. So that we already derived in the step number 6. So the previous example, which is the impedance matrix of the network before the addition of the element number 7. So we have considered the ZBus matrix building algorithm without any presence of mutually coupled elements. In the next lecture, we will take into account the presence of mutually coupled elements while forming the ZBus matrix. So thank you very much, friend. This is the only the subtopic of ZBus algorithm theory. So this is how you can understand the ZBus algorithm by solving the example related to this. We will solve more examples related to this, but this is only for your idea. Just go through all the formulas to form the column and the row of the ZBus matrix. So if you practice more, you can solve the any of the example for the ZBus algorithm. So again, please go through this lecture again and again to solve your doubts. And if you have any further doubts and query, so we can solve this queries and doubts in our doubt solving session. Thank you very much. And if you want to call me, then feel free to call me anytime to solve this doubt. Thank you very much, friend. Thank you all. Jai Swaminarayan.